Okay, so in this particular video, let's understand that how this synchronous and asynchronous operations internally work. Okay, that how JavaScript internally works. Now this is a super duper important video. So let's say that this is your Node.js server. Okay, so this green block is what? This is your Node.js code. So this is JavaScript code running inside a Node environment. Now the architecture goes something like this, that you have a queue here. Okay, so let me just create a queue for you. So here we have a queue. Okay, what is this queue? Just forget about it. Okay, then you have something known as an event loop here. Okay, so this is your event loop, and yeah, so here is the event loop, right? So this particular thing is known as event queue. Okay, this is an event queue. So right here, this is your event queue. Where is the arrow? Yeah, here is the arrow. So you can see that I'm putting an arrow, and here you have an event loop. Now what's going to happen is your event loop is something that is listening to this queue. So let's say you are hosting some web server and a user came. Okay, so this is a user, a pink user. Okay, a user came and gave a request. So what will happen? All the requests that is coming to your server is going to in queue in this particular queue. So this is your user 1. So this goes here. Let's say you are getting a lot of users on your website and everyone is trying to, hit your web server, hit your servers. So what's going to happen is every request your users are making, this gonna get queue in this event queue first. Okay, so this part is fairly simple. Now what this event loop is going to do is, event loop's sole purpose is to watch this queue. Okay, event loop's sole purpose is to just keep a track, that what is just to keep an eye on this particular queue. So if there is something, okay, if there is some data in the queue, event queue is responsible for picking up that particular data in a FIFO manner, that is first in first out, and process that request. So right here, two things happen. Okay, now this part is very interesting. So guys, do you have some data in your event queue? Of course there is, right? So this was the first person that came. So let's pick up this thing. Now what event loop will do, event loop is going to check that what kind of request this is. What kind of request this is. Is this a blocking operation? Okay, it can be either a blocking operation. So let's say that this is a blocking operation, or it can be a non-blocking operation. So you now know, right, what is blocking and what is non-blocking. Now let's say that this task was actually a blocking operation. Okay, so it was a blocking operation. That means you were trying to do something like this. You remember this synchronous version? So what is going to happen is this event loop is going to execute your code. Okay, this event loop is something that is going to execute your code, or I mean, it is basically waiting. Now, if your event loop is busy, right, processing this blocking code, can it pick up more tasks from the queue? Of course not, right? Because your event loop is now busy executing this code. So at this point, can I say that rest of the users are basically waiting for a very long time in the queue? They are getting no response. So at this particular point, your website is going to take a lot of time to load. And the reason, because you have written a blocking code and your event loop is busy, evaluating this code. So this is your first part. Second part, okay, let's see the second situation, what will happen in the second situation. So second situation is that your code was written in a non-blocking manner. Now, if your code is written in a non-blocking manner, now here are two things. Let's say that this particular thing requires a CPU. It's a CPU intensive task. For example, reading a file is a CPU intensive task, right? So what this non-blocking operation does, it basically forwards this thing to something known as a thread pool. So you have a different thing here. Okay, you have a different thing here, which is known as thread pool. So what is a thread pool? Thread pool is basically a pool of worker threads. I'll tell you what is a worker thread. So these are worker threads. By default, you have 4 worker threads which are sitting idle, right? What this is going to do is, it sees that, hey, it's a non-blocking request and it's a CPU intensive task. So this is going to offload this particular task to one of the worker. So let's say that this particular worker got it. Let me just bring it to forward. For some reasons, yeah. So this task is assigned to this worker, and now this particular worker is busy doing this task. While this worker is busy doing this task, your event loop can pick up next task. Let's say your next task was also a non-blocking request. It can go here. It can take one. What do you say? It can take one of the worker. Then this worker is again going to work, right? So let me just bring it to the front. So this particular worker is also working. Now you have two workers. Let's say there is one more request. Now this request is not CPU intensive. It was just a database operation. So it will be executed quickly and it will be resolved. Your one user is happy. So let's say, hey, this user is happy, right? So usually you will have database calls only. So this was also a simple database call. You did a database call. Your user is happy. So this particular operation is also, so this I can also delete, and he is also happy, right? They got the data. Now, once they will complete, because it's an asynchronous process, it will call the callback, right? You remember that callback function? So it has done. So thread will come back and this data will be returned to event loop. This data, whatsoever you have processed, will be returned back to the user, and your user is happy, right? And same thing will go for the last one. So once this is done, let's return the data back to the user, whatsoever he has demanded. He is happy. And if in between more users were coming, we were not blocking anything. So this is your non-blocking request. So your Node.js actually makes use of this thread pool, which is by default 4. You can even increase the size, and I'll show you in the practical way, okay? And these threads are offloaded to work on a CPU intensive task. Okay. Now you might be wondering, Piyush, how can we decide what task will go in the thread pool and what not? Actually, we cannot decide it. Okay. If it's a CPU intensive task, that means it's a heavy task which requires CPU, it will be offloaded to the thread pool. If it is blocking request, then event loop will handle that. If it's a non-blocking, go to thread pool. And if it's a simple IO operation, event loop will handle and resolve the request quickly. So when you are creating web servers, you should always do non-blocking requests, because of course you don't want to block the server. But there are cases where you might want to block the server. Let's say you want to, like, you are doing some kind of leaderboard thing, right? You want to keep things in synchronous way. For example, let's say users are collaborating on a file. So you don't want the file should go out of sync, right? You want that if one user is interacting with a file, other users should wait while one person is interacting with that file. In that way, you might want to use a blocking operation. I am not saying that blocking operations are bad. No, it purely depends on the application use case, right? So you have to decide that whether you want to do a blocking operation here or a non-blocking operation here. Okay. So this was a very, very, very high level of a Node.js working. So this was basically like Node.js from 50 feet away. Okay.